Hello, hi. Okay, my name is Orko, right? It's pronounced as Orko. It's spelled as A-R-K-A, right? And I'm an engineer by profession. I work with a tech company and as a tech consultant, but that has no relevance to what we're going to discuss today, right? What I'm going to discuss is mathematics. It's a subject I love. I consider myself as a student of mathematics. I do it mostly out of my own knack, right? Before I start anything, by the way, this entire series will be in English and Bengali, right? Because Bengali, Bangla, like Matribhasha, it's my mother tongue, so I'll talk in Bengali a bit in between. I'll try to keep it in English as much as I can, but maybe at times that mother tongue will sip in, perhaps. But yeah, and what we are going to learn is basically mathematics. So before I get into any of those subjects, I would like to talk about the motivation behind starting this series, right? Because this is my first video, right, tutorial in any format, right? I've never done this, not on Instagram, YouTube, anywhere for that matter, right? So this is the first time I'm doing it, right? So the motivation behind it is আমি বহু বছর ধরে পড়াচ্ছি বাচ্চাদেরকে, ঠিক আছে? It's been a while, and every time a new student comes up to me and their parents tell me যে আমার বাচ্চা ম্যাথসে ভয় পায়, right? And I don't like this, right? Even with our friends, a lot of my friends, they're afraid of the subject, right? And I don't blame them, right? Because they never had that good teacher who could tell them or sort of understand or sort of help them understand the subject in a better way, right? Show them the beauty of the subject, that is mathematics, right? And not liking a subject is absolutely fine, but not having the chance of looking at the beauty of the subject, I think that's a little sad. So I'm here to like help you guys get rid of that stigma that is associated with maths, right? uh, this won't follow any particular curriculum, right? This won't be any school syllabus sort of a situation, sort of a thing. It's just general discussion of mathematics, right? I'll discuss high school mathematics, right? Maybe bit of set theory, and in all honesty, I've not planned as such, right? I'll start off with set theory maybe, and then we'll see relations and functions, and maybe a bit of algebra, and trigonometry and all that, and perhaps later part we'll look into the calculus. If we do get chance, we'll probably talk of a bit of modern maths, but mostly high school level mathematics. uh, if I do get time, maybe I'll add a college level of mathematics, but I'm not too sure. In honesty, I'm not too sure, right? So I don't want to stretch this video out by discussing what we are going to do in the future. Rather, I want to discuss something that I believe should be the starting point of any video series that is associated with subject mathematics, right? So my first question is, what is mathematics? Now, anybody who's had any form of mathematical education throughout their life, uh, first of all, everybody has learned a bit of maths, right? If it's in your nursery, in your upper KG, or in your middle school, anywhere, right? Basic level of maths everybody has studied, right? So, what is mathematics? Mathematics জিনিসটা কি, খায় না মাথায় দেয়? What is it, right? Is it just numbers, equations, symbols on a blackboard, nightmare for somebody? What is it, right? So there are two ways of looking at it, right? First, we'll look at a formal definition, and then we'll look at an intuitive definition, right? Intuitive definition is something that I have come up with, right? So maybe no teacher will accept this, but it's something I believe in, right? So let's look at a formal definition, right? Mathematics is an abstract science, right? It's an abstract science. It's not I mean, you guys know what abstract means. I need not explain that part, right? So abstract science, or what does it deal with? It deals with numbers, quantity, and space, right? These three, right? These three are much like, this is a branch of mathematics, I'd say. And then there's another branch of mathematics, right, which deals with logical reasoning, logical reasoning, quantitative calculation, and And basically this development, right, this development of this subject that is known as mathematics, what does it involve? It involves study of patterns, structures, and relationships, right? So three things. It's patterns, structures, and relationships, right? Relationships, you'll find it soon enough, and we'll study relationships and functions. Structures maybe later. It's in college level of mathematics, and patterns as well. But to a certain degree, you've all witnessed these things in the mathematics that you've already studied, right? Number, quantity, space, logical reasoning, quantitative calculation, and then study of patterns, structures, and relationships, right? uh, and we use, in mathematics we use two main things, right, which is symbols. Symbols are very important, right? You learn a bunch of symbols throughout your mathematics journey, and we have some rigorous proofs, right? Proof writing is another integral part of mathematics that is not such a massive part of your school mathematics, but it's a huge part in your college mathematics, right? Okay, this is the formal definition per se, right? But let's look at a much more intuitive definition of mathematics, right? Uh, for me, for me, Orkodash, mathematics is a language we use to understand patterns, right? It's a language. Mathematics is a language on its own, right? Mathematics is a language we use to understand patterns, right? What do I mean when I say patterns, right? It can be, in all honesty, it can be anything, right. How does a thing work? How does a motor work? I don't know how many of you have watched Three Idiots. There's a question where this virus asks Raju, how does the induction motor start? So that's mathematics. How does an induction motor start? Mathematics gives a proper answer to that, right? uh, how do things relate to each other, right? uh, in fact it can be anything, in all honesty. How a car moves, right? uh, it begins right from counting sheeps, and then it grows into building bridges, and it can stretch as far as explaining maybe black holes, infinity, whatever, right? In all honesty, that's the sort of intuitive definition of mathematics that I would urge all of you guys to look at, rather than a very formal definition of mathematics of the subject, right. And perhaps I'll also leave you guys with a question, right. Mathematics is sort of a way of asking, right. It sort of asks a question, which is, it's a very important question, right? And I think if you're a mathematics lover, I would urge you guys to listen to this, right? So mathematics is a way of asking, if this is true, what else is true, right? This is a definition, this is a question that will encounter time and again, right. Just keep this in mind, right, for the time being. And always also remember that it doesn't really matter what the answer to this question is, right? It's more about the way we are thinking about it, right? When you get a problem, right, perhaps you have a linear equation to solve, right? It doesn't really matter what the answer is, right? Answer, you can solve it, somebody else can solve it, because the answer to that problem is basically, you have an algorithm and you're putting your equation to it and you're solving something, right? Solving that particular equation, right? And that is the way to go ahead with it, right? That is not what my ask is from you guys, right? What I want you guys to do is rather think about, what does that equation mean, what does it intend to say, right? Because every equation, every mathematical statement has a story to tell, right? I would urge you guys to think about the stories associated with that particular topic, right? uh, that's the sort of, like, if you take nothing from this lecture, I would at least want you guys to take this question with you guys, and this thinking that nothing, like in mathematics, it's less about the answer. Of course answers are important, but it's less about the answer, it's how you think about the topic, right? Okay, now let's begin talking about mathematics, but not with a formula as per se, right? Let's begin with a story, right? A story that sort of began 5,000 years, right? Currently, perhaps 5,000 years in the making. Currently, it's going on in 5,000 years. Now it began with perhaps 3,000 BC, right? 3,000 BC, right? This is where it began from, right? Uh, in Mesopotamia, right? Mesopotamia and Egypt, right? In Egypt, they first introduced a form of geometry, right? Geometry, correct. So when we talk about geometry, right? What do you think of geometry, right? So it is not, this is not the geometry that you study currently, right? It's sort of a form of it, right? For example, the Egyptians used uh, needed mathematics to do a lot of bunch of things, right? Count sheep, divide crops, measure land, right. So when I talk about divide crops, it measure land. So wherever agriculture has come into the human lives, ever since then mathematics has in some form existed, right? We can say that, right? Because of course you need mathematics to measure land and divide stuff, right? It's sort of intuitive, right? Why in mathematics was required, right? uh, in fact, Egyptians also required it to build stuff, right? They built the pyramids and stuff, and so the earlier form of geometry was predominantly used in construction, right? Babylonians, on the other hand, Babylonians, if you've heard of them, Babylonians, on the other hand, gave us number systems, right? The current number system that we use is a decimal number system, right? In decimal number system, the base is 10, right? In this number system, they used a base of 60. Now you might ask why 60, right? Uh, it's an interesting number, in all honesty. There's the number of 60 is the number of minutes in an hour. It's also the number of seconds in a minute, right? So they prefer that sort of number system, right? Minute, yeah, okay. Now Egyptians had I'm sure all of you have heard of the Pythagorean theorem, right? Which is just a moment. Let me draw this correctly. Yeah, okay. Now there's an A, there's B, there's C, right? Okay. This Pythagorean theorem, which gives us a square equal to b square plus c square, right? So which is basically square of the hypotenuse is equal to square of the perpendicular plus square of the base, right? That's the theorem. We know Pythagoras theorem, right? It's one of the earliest form of mathematical formulas that you've come witnessed and discovered, right? uh, of course they did not have the Pythagorean formula, right? It came much later, but what they knew was they needed the right angle, right? For in pyramids they needed the right angle concept, right? Which is the concept of 90 degree. For that they found out a different method, right? Which is they took 12 sheets, 12 different ropes, right? Pieces of rope, right? And it had, and the specific feature that needed to be followed was this 12 ropes needed to be of the same length, right? So it is 1 2 3 4 5 6 7 8 9 10 11 12, right? So this is 12 rows. For example, this is A and B and this is C, right? Okay. Now look at this, right? Between A and B, let's look at the number of ropes that there is there. So there's 1, there's 2, there's 3, there's 4, and there's 5, right? There are 5 ropes, right? Now consider we fix this point A here, and we fix this point B here, and we stretch it out, right? So once we stretch it out, these 5 strings, we stretch it out, right? And from B, look at from B, there's 1, 2, 3, and 4. In B and C, there's 4, right? So maybe from here, there's 4, right? So this is C. So from here, 2, 3, right? So there's 4 strings, right? And there's 1, 2, 3, 4, right? And there's the 5th, right? Please pardon my drawing. It's not that good, but anyhow. Now see the 5 string. If they stretch it out, then they get this. There's 3 partitions here between A and C, right? So this C and this 1, 2, and 3. These 3 are here between A and C, right? So this gave us a 90 degree sort of situation, right? And they tied it out, right? So when they drew this, A used to be on this end, right? So they was a circular sort of a situation, right? So we got a 90 degree at ACB, right? So they had this Pythagorean triplet, which we now know is 3, 4, and 5, right? This is a very famous Pythagorean triplet that we've witnessed time and again, right? So this is the sort of mathematics that Egyptians had, right? Okay. Now fast forward, let's move on to the 800 to 300 BC. 800 to 300 BC. Now this again was a great time for mathematics, especially in India, right? In India, this was the time period when Aryabhatta, I'm sure all of you have heard his name, gave zero, right? Zero, right? And perhaps zero as a concept was so very important, right? I cannot emphasize on how important it truly was, right? It changed everything. In all honesty, it changed everything, right? The mathematics that we today know and use, it's predominantly dependent on zero, right? Parallelly, and if we talk about India, that's it. And parallelly, in Greece, right? If we talk in Greece, right? In Greece, there was this gentleman, which is called, whose name was Euclid. Now Euclid and Pythagoras, in fact, Pythagoras, perhaps, by the way, Euclid, I believe, is perhaps the greatest mathematician that there was, right? Personally, personal favorite. Same with Pythagoras, I think. Anyhow, and Euclid and Pythagoras raised a very important question, which is, how do we know things for sure? Right? This is a great question to have, right, as a mathematician, right? Uh, and perhaps this is where mathematics truly began from, right? The mathematics that is prior to this has always been very intuitive, right? Has always depended on the practical applications of mathematics, right? But true theoretical mathematics, just for the love of the subject, I think that sort of began from this period, right? When Euclid brought this concept of proofs, right? Proof writing, right? He was the first individual who wrote a book on proof, right? The first formal proof, right? Proofs are a great thing to look at, right? If you guys have, I don't know how many of you read about Euclid, but Euclid has a bunch of books, right, in which he has talked about various proofs throughout those his period. Of course, those proofs are sort of different from us. It's mostly geometrical proofs, by the way, but they're fundamentally different from the proofs that we have right now. But for example, I can give you one example. In that book, there's a Pythagorean formula that we know, and the Pythagorean formula, the way they have proved it is, so for example, this is A, this is B, and this is C. So the way they talked of is they used to consider this A, this, it's an interesting thing. So maybe this is a square, right? Again, please don't look into it. This is a horrible square, but please consider it to be one. This is A, right? This A is a square, right? A is a square. Then C is another square, right? And B is another square, right? So if we have three squares, right? So area of square A, if you organize them in this particular pattern, then area of square A must be equal to summation of area of square B and square C. So what is the area of square A? Because it has side A, right? So that's A square equal to summation of area of square B and square C. The square B side is B, right? So which means B square gives us the area of the B, and C square is the area. So this is the how they sort of proved Pythagorean theorem back then, right? Yeah, this is probably where I'll stop yapping as well for the time being. So today we've talked about 3000 BC Egyptians and Babylonians, and then we've come to 800 to 300 BC, where we have talked about India and Greece. Before that, we've sort of uh, we've looked at mathematics from two different perspectives, which is a formal perspective and then an intuitive perspective. And yeah, I think that's a good start for the time being, right? Next video, perhaps we'll talk a bit more about the history, and then we'll reach modern maths, set theory, and then start off with set theory maybe. I'm not too sure how do I intend to plan this series, but yeah, this is where I'd like to start. Next video, for sure, we're going to at least look at the rest of India history till today, right? So there's a bunch of the great Islamic period, and then we will talk about so how they gave us algebra. Then we'll talk about Newton and how they gave us uh, calculus as we know, and then we'll also look into the modern maths, which is set theory. There's a man called Cantor, and he raised a very important question. He tried raising a question about infinity, and we'll look into that, all that. And yeah, and then perhaps we'll slowly start talking about set theory, relations, functions, and yeah. So that's my plan for the time being. But yeah, this is a good place to stop yapping, I think. uh, Thank you. If you guys liked it, maybe give me a good review about it. Any sort of criticism that you felt, that anything that I need to do better, all that. Of course, I'm very new to this. I do not know how to edit videos and stuff, so a bunch of it will be wrong. I'm pretty sure they are wrong. But yeah, just bear with me. And if you want to leave any constructive criticism behind, I'm open to it. Okay, thanks.